Let V and U be two vectors in space. We know that the dot product between V and U is given by V1 times U1 plus V2 times U2 plus V3 times U3. And we know that the dot product may also be given by the product of the magnitudes of the two vectors times the cosine of the angle between them. So let's prove that both formulas are valid. Let's go to the number plane. I'm gonna draw both axes, y and x. Here we have vector v, and here is vector u. So this is v, and this is u. And the angle between these two vectors is denoted by theta. Let's denote by alpha the angle between vector v and the x-axis, and let's denote by beta the angle between vector u and the x-axis. I represented both vectors in the plane to be easier to prove that these two formulas are correspondent. However, the same logic may be applied to space. So let's represent vertical and horizontal dashed lines from the terminal points of the vectors and the axis. We know that here we have v1 and here we have v2, and we also know that here is u1 and here is u2. So we may write the sine of alpha is equal to v2 over the magnitude of vector v, and the cosine of alpha is v1 over the magnitude of vector v. And we know that the sine of beta is u2 over the magnitude of vector u, and the cosine of beta is u1 over the magnitude of vector u. And we also may write that the angle between the two vectors, theta, is given by beta minus alpha. So we may write a trigonometric relation. We know that the cosine of theta is equal to the cosine of beta minus alpha, and we know that this is equal to the cosine of beta times the cosine of alpha plus sine of beta times sine of alpha. So we may write, according to the relations above, we may write that the cosine of theta will be equal to, I'm gonna substitute this by this one here. So we know that the cosine of beta is equal to u1 over the magnitude of vector u. And also we know that the cosine of alpha is up here. We know that this is equal to v1 over the magnitude of vector v, plus the sine of beta. We know that sine of beta is equal to u2 over the magnitude of vector u times the sine of alpha. We know that sine of alpha is equal to v2 over the magnitude of vector v. So the cosine of theta is given by, we may sum here we have the magnitude of vector u times the magnitude of vector v, and here we have u1 times v1 plus u2 times v2, and we can move this to the left side, so we can write like this: the product of both magnitudes times the cosine of theta is equal to u1 times v1 plus u2 times v2. So as we were trying to prove, we could prove that both relationships, both formulas are valid to calculate the dot product of two vectors. That's it.